Good morning, everybody. Welcome to this webinar hosted by Baltic Amadeus. People are still connecting? Let's wait a minute and we will start shortly. Hello again. This is Roberta speaking. I will be the moderator of this webinar. Today I'm joined by my colleague Mindaugas, and Mindaugas is a .NET division lead in Baltic Amadeus. And he will be the main speaker today on topic building scalable web applications with Microsoft Azure services. Before we begin, let's quickly overview how this webinar will be held. I will start with a brief introduction explaining what is Baltic Amadeus so you could have a better understanding of why we speak on today's topic. How does that correlate with our daily business? I will cover some facts, numbers, challenges related to nowadays web applications. Continuing the session, I'll give the floor to Mindaugas, who will explain what is a scalable architecture, how to choose the right software architecture pattern for scalability, how to create highly scalable web applications using Azure services. He will also cover the use case. With this, we hope that you will see the parallels with your business too. Finally, we will finish with Q&A session. Don't hesitate to send your questions during the entire event. We hope we will have time to answer it all, but if not, don't worry. You will get personal responses later. So let's jump into the details. Baltic Amadeus is a Lithuanian-based custom software development company that is in business for 30 years. During that period, we worked with various projects and with customers in Sweden, Norway, Germany, the Baltic states, and outside Europe. Currently, we have more than 200 employees working. When it comes to the cloud service direction, we consult organizations, helping them to get answers on the main question, should I move to the cloud? Then we have modernization and migration package. We help to execute projects for bringing the IT workloads to the public cloud. Next, once the applications are in the cloud, to leverage the full potential, we optimize and automate daily routines. And finally, somebody needs to take care of your infrastructure in the cloud, provide proactive support under agreed SLA. So we do that. We work with cross industries, but most of our experience comes from finance, energy, transport, logistics, and other mentioned sectors. This event is organized in cooperation with Microsoft, and we are very grateful and proud to be part of Microsoft partner ecosystem. At the moment, we have 4 gold competencies that helps us to consult companies and deliver projects successfully. Now you know a bit about us. We would love to get to know you a better too. I have several questions to ask you during the session. You will see on your screen a pop-up window. Just choose an answer that most suits your situation. And here is the first one. What is your experience using Azure services? I'll give you several seconds for answering. Okay, let's move on. Today's business is powered and surrounded by applications everywhere. The purpose of it might be different. There are B2B applications that usually develop to streamline business operations, simplify complex business processes, or fulfill specific industry needs. B2B apps are used by businesses to connect with other businesses. It could be specific websites, product supply and procurement exchange platforms, specialized industry portals, brokering sites, information and data sites. There are applications that helps organizations to manage everyday business activities, accounting, procurement, manufacturing, supply, etc., so-called ERP systems. And then there are applications that helps organizations smartly administer their interactions with customers, like CRM systems. There could be many more: productivity software, resource management, education, time management, etc. All of it could be called internal applications. Finally, we have customer-facing applications that are used daily to serve our vital requirements, get information, or simply entertain ourselves. It could be a food delivery application, insurance portal, any kind of e-commerce platform, or video music content streaming service. And here I have another question. What kind of applications do you have in your company? So I believe that today's modern organization must have many different applications. Both internal and also external facing are essential for success. And then there is the data. Every user interaction with any application works with data, consumes data, and generates data. Business collects tremendous amount of information, and the challenge is how to turn that data into actionable insights and intelligence to provide a superior customer experience. So at this point, I want to emphasize the importance of applications and customer experience. To ground into the importance of customer experience, I would like to start with the Forrester quote that says, more than any other factor, customer experience determine whether companies thrive and profit or struggle and fade. So in today's digital economy, customers are the new market makers, reshaping industries and changing how business compete and win. And your end users have really high expectations. Let me walk you through some of them with some data points. Customers care a lot about a personalized experience. 38% of them won't come back if they have to repeat themselves. They expect that once they provide the information, applications should be able to recognize them over the time, learn about them to deliver the personalized experience. 65% of customers feel frustrated with inconsistent experience across the platforms. Nowadays, customers have many devices, and they expect that their experience to be seamless. 79% of customers won't return to a slow website. You can take a look at the bounce rates for your site to realize the magnitude of the lost opportunities. As you can see, there are some challenges for any applications. So here is my last question. I want to know, do you see the performance or web scalability challenges in your developed digital solution? Again, several seconds for answering. Okay, so digital engagement has evolved greatly beyond the static web content, delivering richer interactivity and functionality. And it isn't different from modern web applications. Websites have evolved a lot during the last several years, and then they are no longer just a public repository or static content that companies can update occasionally. Now a website is a live entity with constant changes. As the main vehicle to deliver digital campaigns and deeper engagement with customers all over the world. This means that the development of these applications must be way more agile, not only in terms of doing quick updates, adjusting to the business needs, but also being able to provide a consistent experience across different platforms, incorporating artificial intelligence capabilities to provide a more personalized experience, conversational bots for faster, more natural interaction with their users. These are just a few ways to provide the high quality experience. And it's easier than ever, thanks to the cloud services in Azure. So that is more than enough for the introduction, and I'm giving over the microphone to Mindaugas now.
Well, hello everyone. Thank you, Robertus, for your beautiful introduction. Today I'm going to take over the presentation and talk about scalable web applications and how you can design and deploy your web application in Azure Cloud. What you're going to learn in today's presentation is I'm going to explain what is scalability in general terms. You will also understand why scalability is important and why you will likely face performance issues if you don't consider scalability in applications design. What are two different ways to scale application and how they are different? You will also understand what is Scale Cube and how you can apply it to design scalable applications. I'll also go through one use case, and you will see how a monolith application was transformed to a more scalable solution. In addition to everything mentioned, we are going to focus on Azure Cloud, and I will be briefly introducing you to some of Azure services which we were using to achieve more scalable solution. So let me start from some theoretical basis, and let's define what scalability is. In the broad sense, scalability is the ability of the system to handle increased load. Often, scalability might be described as the ability of the system to add additional resources without modifying the application's code. Why you should care about this scalability? Most of the web applications are designed to directly interact with users, which means that the web application should not only deliver the business value by its functionality means, but also ensure consistent user experience. And what happens when an application gets pushed to its maximum load? We start to see two things: increased response time, and in some extreme application, in extreme cases, application might not even respond at all. In both cases, you most likely will start to lose your users. As Robert has mentioned before, up to 79% of users want to turn to slow websites. Of course, you can also face some service level agreement penalties, and simply put, you can get a bunch of angry users. So in other words, we want to have application that runs consistently no matter what the load is. It is important to understand that solving the issues when application is on fire turns out to be a very costly practice. Let's inspect the scalability pyramid, and let's see, maybe it explains why it is costly practice to redesign application. Purely from a theoretical perspective, scalability should be considered more application feature designed during the requirements and design phase rather than application or product hardware tuning. And this concept is perfectly illustrated in this pyramid. As you can see, climbing up the scalability pyramid, impacts on scalability are reduced. This brings us to understanding that most impact on application might be achieved only by redesigning the application itself, which is always costly practice. What are the methods to scale? Basically, we have two methods to scale, and the first one is by changing your hardware on which you are running your application to more performant, having more memory, CPU. This method is called scaling up or vertical scaling. In contrast to scaling up, we have a scaling out method, which is achieved by using many machines to achieve desired performance. Scaling out is also called horizontal scaling. What are the features of vertical scaling? The advantage of scaling up is that your application doesn't have to be designed for scalability. You just switch to the bigger server, which can handle increased application load. Of course, sooner or later, you are going to face the scalability limits, since you will not be able to add additional RAM or CPU to your server. Having big and performant server might turn out to be costly. Another downside of this approach is that scalability achieved with this method is not linear. Doubling the server specification not necessarily results in ability to handle double requests per second. What are the features of the horizontal scaling? Scaling out is achieved by using many machines to achieve desired performance. This type of scalability requires application to be specifically designed to be scaled horizontally. In ideal scenario, doubling the amount of servers should result in linear performance increase. In addition to performance increase, By adding more servers to your, you are eliminating the single point of failure, which means that if one of the servers is down, your application will continue to work on other servers. Of course, having this horizontal scalability presents a set of challenges you have to deal with. For example, load balancing requests to your servers. It is also important to stress that in any scalability model, all components of the system must be scalable. Otherwise, by scaling one component, you will hit a bottleneck in different component. Typical example would be a web application and database. If you scale only web application component, we will eventually hit the database throughput limits. And after this point, no matter how well your application's code is running, the database request will slow down all the system. Which method of scalability you should prefer? Martin Abbott and Michael Fisher in their book Scalability Rules advises that the best practice is to design application to scale out. When designing or refactoring the application for horizontal scalability, we need some reference model that would guide us how to think and communicate about the application in scalability terms. Here we will refer to the scale cube. The scale cube described by Martin Abbott and Michael Fisher in The Art of Scalability is an extensive model that allows us to think about how to split services, data, and transactions. In its essence, the scale cube has 3 axes. The initial point is the point of least scalability. It consists of single monolithic system deployed to a single server. Let me point that in diagram. Each axis represents the type of modification to our system is called the split. The X-axis split represents the application of the services, servers, cloning without any biases. The X-axis split is the best when we need to perform more work, just add more capacity by cloning our servers or services. Implementation of X-axis split is fairly inexpensive. On the other hand, Y-axis split represents functional decomposition. For example, monolith web application might be split into smaller microservices like payment transactions, search services, product catalog, and so on. This type of split, first of all, helps us to manage the growth of transactions. Secondly, services can be more specialized, resulting in higher throughput per system basis. And it also introduces the first level of fault isolation. Y-axis split is more costly to implement since it requires more investment in redesigning application code and processes. Also, it might result in initial increase of operational costs since separate services creates a resource underutilization. And lastly, the Z-axis split represents recommendation by a requester or customer. This type of split most often addresses monolithic nature of data. For example, application might be split to the separate services by customers, geography, and moving services closer to the customers, or even separating the data for specific region. Z-axis split are most expensive to implement, but also have significant impact on application scalability. Up to now, I covered some theoretical ground here, but before diving into real-world scenario, I should also talk about Microsoft Azure. As you already know, Azure is the cloud computing services operated by Microsoft. Azure provides different services which might be grouped to 3 tiers. Software as a service, platform as a service, and infrastructure as a service. As well, it supports multiple tools, frameworks that generally simplify scalable solution development, deployment, and management. I'll describe some of those services in more details later on, but for now, it's important to know that we as application developers mostly focus on application as a service platform. since it gives us infrastructure needed to deploy scalable application and allows to create application using built-in software components. So after all that been said, let's focus on our initial architecture. And let's start analyzing our use case. Here I have presented the initial architecture of pretty typical web application that we started working on a few years ago. Main idea was to provide some financial data and analytics for business investors. Right from the beginning, application was designed as a basic web application with some scalability in mind. The code was mainly based on .NET MVC framework, minimal JavaScript for AJAX calls. In fact, this design already allowed us for X-axis split by simply cloning an application and load balancing HTTP requests between different instances. Not to mention that we had some drawbacks with this design. The first one was that the basic web app server had to save the session state for access control, auditing, and other business logic to be performed correctly. Thus, load balancer had to be configured with session affinity. This method is also known as sticky session. This approach works fine, but for bigger application loads, there is a potential risk that you will not have optimal resources utilization. We also had a single application, which meant that grouping functionality to application got more and more complex to support. Also, it meant that we have a single point of failure. And we anticipated that single database eventually would become a bottleneck. The good thing, though, was that the application was deployed in the cloud. And one of the benefits of the cloud is that you not only get infrastructure, but you can also easily manage computational resources and even have some scalability out of the box. For example, in this case, the application was deployed as an app service. This allowed us to scale the application to some extent without additional design considerations. So what is the app services in Azure? The app services is a cloud computing platform for hosting websites. There are quite a few elements you have to understand about the app services. The first concept to understand is a app service plan. The app service plan defines a set of computing resources for web app to run. It's like a virtual machine specification, if you like. App service plan can host many app services, where app service is a container for a web application. With app service, you get quite a few options to scale your application. In dedicated or isolated tiers, you can scale up or down your application by choosing right amount of CPU and RAM for your instance. You can also scale out by configuring app service plan to run multiple instances. Each instance is an exact copy of your app service plan. App service even provides the load balancing, which can be configured automatically or manually. Another handful feature is auto-scaling. Auto-scaling is the ability to specify to your app service plan when to create or shut down new instances. This way, you can increase your application capacity when load increases or reduce capacity when load reduces. By doing so, you save the operational costs. Auto-scaling allows you to trigger scaling based on requests, CPU load, or even predefined schedule. And if this is not enough, you can even configure global scaling by by configuring traffic manager between geographically separate regions. The first try to refactor our application in order to improve its scalability was functional decomposition. Front-end and back-end was split into separate applications. For implementing the front-end part, we used React application framework, and the back-end simply exposed REST API endpoints. So here we had the React with front-end part, and here we had the back-end part. This architecture allowed us to get rid of session affinity. Also, with this architecture, now we had a clean code separation, which led us to better maintainable solution. This interesting thing here to note is that at this stage, we had to introduce Azure Storage Account. Front-end with the static single-page application content was moved to the Azure Storage Account service. So let's see what Azure Storage Account is. Azure Storage Account is a cloud repository for data. It supports different services for storing different types of data. In our case, we'll focus on Azure Blob. Blob stands for binary large objects. In Azure Blob storage, you can store any binary object, images, documents, media files, log files, text files, or any other data. The Blob storage is massively scalable. It can handle almost 20,000 requests per second. The Blob storage also is accessible by HTTP or HTTPS protocol. This means that no web server is required, almost zero configuration, and hidden load balancing, CDN ready scalability out of the box. So we use Blob storage for our static content, and this allowed to achieve instantaneous massive scalability of a front-end application. In the next stage, we continued working on our functional decomposition, and even more fine-grained applications started to appear in our applications architecture. We had an application for authentication, the one for front-end API, basic API, mobile API, 2 React apps. At this point, we started to shape our architecture more towards microservices-oriented architecture. Here, we already used an application gateway that allowed us to balance application to load more effectively HTTP requests. A very important element of this architecture is Azure SQL Server Geo-Secondary Replica. Basically, we had the primary server, which handled read-write operations, and read-only secondary replica. This approach eliminated a single point of failure at database level and allowed to redirect read transactions to secondary replica, thus reducing the number of transactions on primary database. Well, I suppose I don't have to explain what SQL Server is. I'll just mention that in this case, we use Azure SQL Database, which is a fully managed platform as a service database engine. The benefits of the Azure SQL Database is that it automatically scales to support increased load, and you don't need to worry about availability. Well, at least Microsoft states that it runs 99.995% of SLA. And by configuring geo-replication, we also enable the horizontal scalability. And finally, here I'm presenting the current architecture. In fact, in the slide, I'm sharing the simplified architecture of the application. I already mentioned that we have had a single app service plan, where we had hosted all the application with so-called endpoints. The idea is that here we introduced the Azure functions. And why we needed Azure functions. The application allowed us to export and import data, and both operations managed a considerable amount of data that created a significant load on our application. And Azure functions are services, serverless services that can handle long-running asynchronous tasks with scale, thus allowing us to take out load of the application itself. So here, as you see, we have a one durable function which handles the data import directly to primary database, and in the secondary replica, which was designed to read-only copy, we had a couple more Azure functions which were triggered by the HTTP trigger to prepare data for export. And here you can see also that application allows to export data in 3 different formats: in Excel, Google Sheets, REST API. So basically, user puts this request either from application or from REST API. Here we have API management services and the Azure function, which collects all the data necessary and transforms to appropriate format and returns it to the user. Well, let me dive a little bit deeper in Azure functions. As I already mentioned, that Azure functions addresses to the functions as a service category of the cloud computing services. This platform enables us to develop, run, and manage application functionalities without the complexity of building and maintaining the infrastructure. Building an application with this model is one of the ways to achieve a serverless architecture. Azure functions are one level higher abstraction than app services, since here we don't have to deal with app service plan. As I already mentioned, we used HTTP trigger to activate functions and consumption plan that scales automatically. We pay only, in this plan, we pay only for the resources when applications are running. And the first million of requests, I think, is free. So summarizing all in all, here's the list of the main technologies which were used in our architecture. The API managed were used to manage and secure existing APIs. Azure functions were used to execute long-running data import and export operations. Application gateway for load balancing HTTP requests. App services to host web application and API endpoints. Azure SQL Server as primary database storage. And finally, the storage account for serving static front-end applications. Of course, our proposed and implemented architecture is not the only architecture you can implement with Azure services. There are many alternatives. And here I'm listing a couple of possible alternative services that we could use. For instance, Azure Container App is fully managed serverless container service that is higher level abstraction built on Kubernetes infrastructure. Basically, you get benefits of Kubernetes, yet infrastructure layer is given from you, and you don't have to deal with Kubernetes management, which is great since it facilitates and greatly simplifies application deployment and management process. Another service is Azure Static Web App, which is designed specifically for static applications that you could integrate directly into your continuous delivery and deployment pipeline. Summarizing all what's been demonstrated, we can conclude that Azure Cloud Services enables us to build scalable solution, less worry about infrastructure, since almost every Azure service has scalability in mind. And there are many ways to achieve scalability and scalable deployment. Probably you always should search for optimal configuration that is feasible in your particular case. So I'm done with my part and giving over to Robert.
Thank you, Mindaugas. A lot of great insights, and I loved your theoretical piece of content and also great insights about the practical use case which you have covered today. Just a quick question, Mindaugas, are we going to share the slides with all participants as well?
I think yes, we should definitely do that.
Okay, that's great. Yeah, so we will switch to the Q&A session soon, but before that, I want to briefly inform you about Azure Marketplace. You know, sometimes when we talk with the people, we hear from them, oh, okay, I really like what you are saying, and cloud opportunity seems to be reasonable to consider. But I need more details. What should be the next steps? What is the concrete offer, and how much does that cost? So for these situations, we created standardized service offers that have pretty clearly defined objectives of service, scope, and pricing. Uh, for example, if you intend to build a modernized application or you want to implement a data analytics solution on Azure, you can go to the Azure Marketplace and check our service packages. So if you are interested in it or you want to learn more, please click the link we share and then press contact me. So I believe this is a great opportunity to get professional support now. And now we are starting questions part. So let me check what do we have at the moment. Oh, yes, so here is the first one. So Mindaugas, I think this is for you. Tell me, how did you measure an API load?
Well, Robert, it's a great question, and I think I didn't mention that in my presentation. The load testing in order to ensure that scalability meets your application needs is a crucial part. In our case, we used Azure DevOps load testing tool, and I think that we should have been using that tool a little bit more.
Okay, great. Another one is, of course, related to the financials. So, can you tell us what could be the approximate Azure expenditures for such or similar architectures in case somebody wants to develop something similar?
Well, nice question. When preparing for this presentation, we compared this particular client expenditure and also we tried to calculate other estimates. So basically, it turns out around 4 to 5K USD per month. And it's also worth noting that most of the costs will be to support database and application services.
Yeah, I see. Great. Okay, I will check for another one. Yeah, there is a question about users. So, how many users the platform currently has?
Mm, well, actually, it's tricky question. Since let me explain that. Let me break it down for you. Uh, in fact, we have 15,000 registered users. Out of those 15,000, we have around 10,000 active users who are using application, and around 100 concurrent users which are daily using application simultaneously. So basically, yeah, this is my answer.
Okay, so let me just clarify. So it means that even though the application currently has up to 100 or something around 100 concurrent users, so but in essence, it is the architecture of it could keep many more users that it is at the moment. Is that right?
Uh, yeah, it's right. Application, as I showed, as I demonstrate, is designed to be scalable. So we are ready to handle increased load. But naturally, if the load will increase, we will need more resources to support our application, and the cost probably will grow up.
Okay, understood. Great. So are there any more questions? At the moment, I can't see. Okay, if no, then I think, yeah, I think then we reached the end of this event. So thank you for your time and participation. I hope it was interesting for you and you have learned new things. If you need more help or support, or maybe you have some additional questions, so feel free to contact us directly. To all participants, we will send a follow-up email with slides as well. So on behalf of our team, I wish you good luck. We are looking forward seeing you next time. Bye bye.